Hey guys, it's Miss LaGrone. I am back again for week 5 of your chemistry journey, and today we're actually talking about, I know I've said my favorite subjects as we go along, but this one truly is top for me. It's stoichiometry, and that is a crazy long word. So we're going to talk a little bit about what stoichiometry is today. You're going to need a couple things. You're going to need your calculator, and you're going to need a periodic table. So take a minute to go grab those two things, and we're going to go ahead and start in. Well, what is stoichiometry? If you remember back to last week, we talked about conversions. We talked about how you go from atoms to moles and how you go from moles to grams. And we're going to continue our discussion with that this week. We're going to look over here at the formulas or the conversion factors that we used last week. And these are the only ones that you're going to be allowed to use. So the first one is moles of A. Is 6.02 times 10 to the 23 molecules or formula units or representative particles of A. These things have to be the same chemical. This is what we did last week. Last week at the end, we also followed up with moles of A over grams of A. And you found that one went with mole and that grams came off the molecular weight from the periodic table, that decimal place number at the bottom. We're going to add one conversion factor today, and these are the only 3 you will ever use in stoichiometry. And it's going to be moles of A over moles of B, and it's going to be how you convert from one chemical to another chemical. So what is stoichiometry? Stoichiometry is measuring how much of one substance you have compared to how much of another substance you have. So for example, if you have a chemical reaction, something like A plus B goes to give AB, and if you remember from week 2, that's called a synthesis reaction. If I know how many grams of A I have, I can predict how many grams of AB I'll produce, and that's what stoichiometry is. It's using quantities to figure out how much stuff you have to see how much stuff you're going to get, and that's what we're going to do today. And as long as you remember the rules, which are start with your givens, write a balanced chemical reaction, and keep crossing out until you get what you want, which is what we've done the last 2 weeks, you're going to be okay. But before we do that, I want to do a reaction with you. So if you look at this, this is C2H5OH, that's actually ethanol. I'm going to react it with oxygen, and I'm going to get carbon dioxide and water. Again, this is a combustion reaction, and it's already balanced for you. And the reason I'm showing you this reaction is because we're actually going to come back and do some calculations with what we find here. So I know y'all get super excited when I pull my hair back. So I'm pulling my hair back, and I'm putting my safety goggles on. And what I'm going to do first is I'm going to get some ethanol, okay? So ethanol is a flammable alcohol. It's got the formula C2H5OH because when you're naming organic compounds, and this is an organic compound, F is the prefix 2. And this is not wanting, of course, live TV. This is not wanting to open, so we'll find a way. So I'm going to take some of this ethanol, and I'm actually going to pour it into this Kentwood water jug. Okay? And what I'm going to do now is I'm going to swirl it around because ethanol really likes to be a gas. So a lot of the liquid that's in here is about to turn into a gas. It's vaporizing is what's going to happen. Okay? So you can see that there's a little bit of liquid left in the bottom, and I want to make sure I get all those vapors around in the bottle. So what I'm going to do now is I'm going to pour this out. So all that's left in here now I'm going to put a lid on it so it doesn't escape, are the vapors of the ethanol. So there's no liquid in here. Right now, most of the liquid is out. There's a couple drops, but most of this is gas. So we all know in combustion reactions, we have to add some energy. And we're going to add energy by adding heat. So what we're going to do now is I'm going to take the lid off and I'm going to add energy to start this combustion reaction, which is going to turn that ethanol, with the oxygen in the air into carbon dioxide and water. And usually when you have a combustion reaction, they release heat and light. So we're going to see if we release some heat and light here. All right, so that was the reaction for the combustion of ethanol. So what do we have in this water bottle right now? Okay, we completed the reaction. So in this water bottle now, we no longer have ethanol or oxygen. There's some oxygen in there from the atmosphere. We've converted that into carbon dioxide and water. And we're going to come back to this reaction at the end, and we're going to talk about how much water we formed to figure out how much of that ethanol we actually used. So again, get your math hat on and go grab your calculator. The first thing you have to do in these problems is write your balanced chemical equation, and that's actually what we did back in week 1. Then you're going to start with your givens, which is what we've done the last 2 weeks. You're going to keep doing your X in a line and crossing out until you get to the unit that you want. Then you're going to do your math and check your answers, and we'll be done. All right, that new conversion factor that we talked about. 2 weeks ago, we talked about moles and Avogadro's number, representative particles. And we talked about converting moles to grams. This week, we're adding a new conversion factor that's going to be moles of A over moles of B. And these numbers come from the balanced equation. They actually come from the coefficients in that balanced equation. So these numbers aren't always going to be 1 and 1. They're going to be whatever the coefficients are in that equation for that reaction. So let's look at this. How many moles of Fe2O3 will you form from 5 moles of Fe? Remember, our first step was we had to write a balanced chemical equation. So if you can't write a balanced chemical equation from words, which is what we did in the first week, you're going to find yourself in a little bit of a pickle. So let's look up here and see if we can write this reaction. How many moles of Fe2O3 will I form? If you're forming that, that means it's a product. So we're forming Fe2O3 from iron. So we're starting with iron. Well, we're not just starting with iron. If I get iron 3 oxide, I have to add some oxygen in there. So oxygen is another one of my reactants. So now we have to balance it. I have 2 Fe's here, 2 Fe's here, 2 oxygen here, but 3 here. When I see those numbers 2 and 3, that means I'm going to have to find some sort of common multiple between those numbers, which is going to be 6. So that means in front of this oxygen, I'm going to put a 3 to give me 6. And in front of Fe2O3, I'm going to put a 2. That 2 times 3 gives me 6 oxygen. So now I got to fix my iron. I have 4 iron on this side, 1 on this side. So in order to balance, I'm going to put a 4. So that's step 1, write the balanced chemical equation. The next step is start with your given. And your given in this case is 5 moles of Fe. So I'm going to start with 5.0 moles of Fe. Make sure you write your chemical. We're going to do the same process we've been doing for 3 weeks now. The next step is you draw an X and a line. You take the unit you want to cancel and you put it on the bottom. So on the bottom, we're going to put moles of Fe. Well, I'm trying to get to moles of Fe2O3. So the only way that I can change chemicals in my conversion factors are by using this third one, which is moles of A over moles of B. So I'm going to come back over here, and on top of moles of Fe, I'm going to put moles of Fe2O3. Now, where did I say those numbers came from, those moles over moles numbers? I said that they came from the balanced chemical equation. They actually come from the coefficients. So I'm going to look at Fe2O3, and the number in front of Fe2O3 is a 2. All right, I'm going to look at Fe, and the number in front of Fe is a 4. All right, So now we're going to cross out. You're crossing out moles of Fe and moles of Fe, and you're left with moles of Fe2O3, which is what the question asked for. So I'm going to hit my equal sign, pull out my calculator, and in your calculator, you're going to put 5 times 2 divided by 4, which is going to give me 2.5 moles of Fe2O3. Do yourselves and your teacher a favor, make sure you circle that or highlight that. So it's just what we've been doing for 3 weeks. You start with your given, you keep drawing X's and lines until you get to what you need to. So let's try this one. Ammonium nitrate decomposes into dinitrogen monoxide gas and water. So we're going to try and figure out what this reaction with. Ammonium nitrate. Ammonium is NH4 with a positive 1 charge. Nitrate is NO3 with a negative 1 charge, so those charges cancel out. It says ammonium nitrate decomposes. So this is a decomposition reaction into dinitrogen, which is N2, monoxide is O, and water, so and H2O. So we've written the reaction. The next step is balance the reaction. I have 2 nitrogens over here, 2 nitrogens over here. I have 4 hydrogen right here, but I have 2 hydrogen here. So right here, we're going to add a 2. So that gives me 2 nitrogen, 2 nitrogen, 4 hydrogen, 4 hydrogen. I have 3 oxygen over here, and I have 2 oxygen here and a 3rd one right there. So I'm balanced. So the next step is start with your given, which is 25 grams of ammonium nitrate. So I'm going to start with 25.0 grams of NH4NO3. I'm going to draw an X and a line. The next step is move the unit you want to cancel to the bottom. So on the top, I'm going to put grams of NH4NO3. On the top, I'm trying to get to determine the amount of water. And usually amount means grams. We're going to try and take this to grams. So I've got 25 grams of ammonium nitrate. I've gone from grams of ammonium nitrate, and somehow I want to get to grams of water. Can I put grams of water with grams of ammonium nitrate? No. That's not one of your 3 conversion factors that you can use. There's no gram to gram conversion on there. The only thing that I can go to grams from is to moles. So instead of grams of ammonium nitrate, I'm going to take that to moles of ammonium nitrate. When you have grams and moles together, 1 goes with moles, and grams, remember we learned this from week 3, grams comes from the periodic table. So I'm going to go over here to my periodic table, and my formula is NH4NO3. So N is 14.01, hydrogen is 1.01, but there's 4 of them, so we're going to do 4.04. N, there's another N, which was 14.01. And then we have 3 oxygen. Oxygen, the weight is 16, but we have 3 of them, so you're going to need to multiply that by 3. That gives me my formula mass for this compound is 80.06. So now I'm going to cross out grams and grams of ammonium nitrate, and I'm left with moles of ammonium nitrate. But that's not what I want. I want to get to grams of water. So I'm not done. I need to draw another X and a line. So on the bottom, we have moles of ammonium nitrate on the top. So to get rid of it, we're going to put moles of ammonium nitrate on the bottom. Now I'm trying to get to grams of water. Can you put grams of water with moles of ammonium nitrate? And the answer is no. You can't mix chemicals when you have grams and moles. If it's moles of A, it has to be grams of A. The only place you can change chemicals is a molar ratio. So on the top, we're going to put moles of water. because that's the chemical that you're trying to get to. Now go back and look at your ratios. Where did we say the numbers for moles and moles came from? Those numbers come from the balanced equation. So let's look up water. Water had a coefficient of 2, and ammonium nitrate has nothing in front of it, so it's a coefficient of 1. So we cross out moles and moles of ammonium nitrate. You're left with moles of water. That's not what you want. You want grams of water. So we're going to draw another X and another line, and I'm just moving down to the bottom. On the bottom, we're going to need to put moles of water to cancel out. And on top, we can finally put grams of water, because that's the same chemical. When you're changing grams to moles, we're using this second conversion factor. We're going to put a 1 with moles, and grams comes from the periodic table, and if you add that up, you're going to get 18.02. So I'm going to cross out moles of water, moles of water. I'm left with grams of water, which is exactly what you wanted. So I'm going to put this in my calculator now. Remember, anything across the top you multiply, and anything across the bottom you divide. So I'm going to say 25 divided by 80.06 times 2 times 18.01. And that is going to give me, don't forget I want 3 sig figs, that's going to give me 11.2 grams of water. All right? So what we're going to do now is we're going to go back to that reaction that we just did a minute ago. That combustion of ethanol. If you look back in this container, there wasn't any liquid in it to begin with. Remember, I got rid of it all. But if you look now, there's liquid in here. What is that liquid? That liquid is water. It's the water that was created by that chemical reaction. So what we're going to do is measure in grams how much water we collected to figure out how many grams of ethanol we used. So I'm going to put a beaker on the scale, and I'm going to zero it out. And then I'm just going to pour the water in. And we're going to have a little error here because some splashed out, and I'm not going to be able to get every bit of it. But it looks like we created 10.1 grams of water. So let's do a new formula with this, or a new problem with this. If I collected 10.1 grams of water from combusting that ethanol, how many grams of ethanol did I start with? Okay, because we didn't measure out how many grams were in there. It was all in a gas, so it's hard to measure weight when you have a gas in there. So what we're going to do now is the same process that we started. So we're going to start with our given. And actually, I am going to move over to this side. We're going to start with our given, which is 10.1 grams of water. We're going to do the same procedure. You draw an X and a line. You put the unit you want to cancel on the bottom. So on the bottom, we're going to put grams of water. And what are we going to convert that to? Grams of water can convert to moles of water. So on the top, we're going to put moles of water. When you have grams and moles together, look at your conversions. 1 goes with mole, and 18.02 goes with grams. You cross out grams and grams, and you're left with moles of water. It's not what you wanted. We wanted to get to grams of ethanol. So I'm going to draw another X and another line. On the bottom, I'm going to put the unit I want to get rid of, which is moles of water. I want to get to grams of ethanol. Can you put grams of ethanol with moles of water? No, those are 2 different chemicals. Remember, the only way you can change chemicals is a mole-mole ratio. So on the top, we're going to put moles of ethanol, which is C2H5OH. Where do those numbers come from for mole-mole? They come from the balanced equation. So with ethanol, we're going to put a 4. With water, we're going to put a 6. We're going to cross out moles and moles, and now we're left with moles of ethanol. We don't want moles of ethanol. We want grams of ethanol. So I'm going to do another X in a line. On the bottom, I'm going to put mole of ethanol. On the top, can I put grams of ethanol with moles of ethanol? And the answer is yes. They're the same chemical. So on the top, I'm going to put grams of ethanol. When you have grams and moles, where do grams come from? When you have grams and moles, grams come from the periodic table. So I'm going to add that up really quick. Carbon is 12.01 times 2, plus hydrogen, there are 6 of them. There are C2H5OH, there's a 6th one at the end. So that's going to be 6.06, plus my oxygen is 16, which is going to give me 46.08. When I have grams and moles together, 1 goes with moles. So I cross out what's on the top and the bottom, and that leaves me with grams of ethanol, which is exactly what the problem wanted. So we're going to see how much ethanol I actually poured into that bottle, swirled around, and actually reacted. So in our calculator, multiply across the top, divide by the bottom, we're going to say 10.1 divided by 18.02 times 4 divided by 6 times 46.08. And that's going to give me 17.2 grams of ethanol. So there were 17.2 grams of ethanol in that container when I ignited that fire. Okay? And that gave us the 10.1 grams of water that we collected at the end. So that's all we have for this week, but stay tuned for next week. Next week we're going to take this a step further and talk about limiting reactants. Yet again, bring your calculator and bring your periodic table, and we will see you guys next Wednesday at 1:30. Have a great day, guys.